Hello my dear students, I hope you are enjoying yourselves and hope you are enjoying CE 2219. So this is the tutorial sheet A2 which we are going to begin with. I recommend that we really follow these tutorials because this is what you'll be answering in tests and quizzes and exams. Because you are many, we can't manage to meet physically. So we'll be using the online platform for tutorials, and then if people have questions, then they'll be coming to ask. Usually we'll take our Friday 1 hour for questions. I know it will not be enough, but at least we should try to do what we can. Okay. So our tutorial sheet first question says, for each of the following, determine the XYZ scalar components of the resultant force. Then express the resultant force F in Cartesian vector form and determine the direction angles alpha, beta, and gamma. Alright, because it's a video, I don't want to bore you, so I'll be a bit fast. Okay? And so please just follow along. So we'll do our first question, which is I. Okay, let me just zoom on it. Okay, there. Probably that's too much. Too much. Let's just take it like that. Okay, so let's move on now. So we've been given the angle of 130 degrees from x axis to f prime. Then we've been given the 25 degrees from the xy plane to f, and we've been given the magnitude of f to be 1000. So we need to resolve its components into the xyz. So we are supposed to use just some basic SOHCAHTOA here, and we'll be able to get the answers. So let's start. So which color would I pick here? That one. Okay. So we know that to find the FY, which is this one here, FZ, that would just be the sine f times the sine of 25 degrees. Then we can also find the f prime, which is that dotted diagonal line from where the 25 degrees is originating from. It's called f prime. And then when we use f prime to find the x component and the y component of f. So without further ado, let's just do that. So coming here, we know that this will have what? Let's start with our FZ. We know that we'll have FZ is equal to F sine 25 degrees, which will be equal to 1000 times sine 25 degrees. This will be equal to, if I punch on my calculator, okay, this will be 422.618. Alright, okay, degrees. Then I'll find my f prime to be equal to f cos 25 degrees, which is equal to 1000 times cos 25 degrees. This will give me this is cos 25, right? This is giving me 906.3 307 degrees. Okay, then from here, dear student, you use this f prime you have found. Why did I start in the mid? Anyhow, it's fine. You use this f prime you have found to find fx and fy. So then we say that fx will be equal to f prime multiplied by since this 130 degrees is on the x component and the angle is being measured from the x component, in this case it will be cos 130 degrees. Okay, so then we see that this will give us, this is equal to 906.307 cos 130 degrees. This will give us -5. Okay, let me just do that, times cos 130. -582.56 degrees. Okay, sorry, no, this is not degrees. How can I be saying degrees? So this is pounds, again this is pounds, again this is pounds. Okay, sorry about that. I guess there's a lot of degrees in my head. So it's pounds. The final answer is pounds. Fy is equal to f prime sine 130 degrees. Okay, which will be equal to the f prime time, anyway, this will be equal to 906.307 sine 130, which is equal to so we are saying 906.307 times sine 130. So this is 694.271 pounds. Okay, so we found fz, fy, fx and fy. Okay, so we are good to go. We have answered part A. So for those who need to know, the first answer is this one, the second one is this one, and the third one is this one. We say that you can, for those who are good students, you can actually what's this now? Okay, instead of using this 130, you know that coming to the tutorial sheet, you know that this angle there between the x and the y axis is 90 degrees. So you can subtract 130 minus 90 and you have your 40 degrees there. Now to find the x component, then now you change here, you say f prime sine 40, and then your y-axis will be the one which will be f prime cos 40 degrees, and then for the fx, you just do by observation to see that okay, the negative is this side. So let's take note of that. It's not always that fx is always a cos. It depends with what angle you are given. Alright, so now let's go to B. For B, we are told to express the resultant force in Cartesian vector. I have the x, the y, and the y. So then my Cartesian vector form for F as a vector is equal to fxi plus fyj plus fzk. So this is equal to, I hope my space will be enough, 582.56i 694.27j, and then plus 422.62k, and then I put everything in brackets and put pounds outside there. Done. Okay, so this is the answer for the other one. So we are saying this is the answer for B, the first part. Then we know that for the second part now, okay, where we have to find angle alpha, we know that alpha is equal to cos inverse of fx, which is negative 582.56 over the magnitude of the force, which we've been given to be 1000. And so our alpha is equal to, as we saw, that should be cos inverse over negative 0.582, which is 125.6 degrees. Beta is equal to the same, cos inverse of 694.27 over 1000, which is equal to okay, 694, which is equal to 46 degrees. Okay, that's your beta. And then your gamma is equal to cos inverse of 422.62 just a little setback in the technology there, over 1000, and this is equal to it's equal to 64, no, 65 degrees, 64.99999, which is 65 degrees. So your gamma is equal to 65 degrees. And you're done. So this is answer, and then answer. Alright, dear students, thank you very much. I hope this has been a bit helpful, and